right, let's go ahead and get started with Chapter 4 in Unit 10. Our objectives for today: I will understand the difference between fixed and variable expenses, and I will create an expense equation based on fixed and variable expenses. Here's our vocabulary for the unit. Make sure that you familiarize yourself with this before moving on with the video. And let's get started. First example, the art students have researched all of the potential expenses. The fixed expenses are $17,600. The labor and materials required for each pair of painted jeans is a cost of $7.53. Represent the total expenses as a function of the quantity produced, Q. So the first thing we need to recognize is, again, Q is number of units at a cost of $7.53 per unit. And so our variable expense formula is variable expenses equal 7.53 times Q. Now our fixed expenses are the $17,600. And that's what they are no matter how much is produced. So let's talk about some examples of variable versus expense. A variable expense might depend, it's going to depend on the number of items produced. It might be the cost for raw materials. As we've seen in previous units, a lot of times there's given a discount. The more that you get, the lower your price is per unit. So the more that they produce, it tends to be that it lowers the cost of those variable expenses. Whereas fixed expenses, things like having to buy furniture for employees to sit at, a computer for them to work on, the lights have to be on while they're working. Those are all examples of fixed expenses. So overall, my expenses are my variable expenses plus my fixed expenses. So my expense equation is going to be 7.53 Q, which is my variable expenses, plus the 17,600, which are my fixed expenses. All right, please press pause. Go ahead and solve this. When you're ready, come back and we'll work it together. Okay, a widget manufacturer's expense function is E equals, and I'm going to rewrite it down here, 6.00Q plus 11,000. So first let's identify that here are my variable expenses to produce the widget, whereas here are my fixed expenses. And it's asking what are the variable costs to produce one widget. One widget then costs $6. All right, example 2. Kivetsky Ski Supply manufactures hand warmers for skiers. The expense function is E equals 1.18Q plus 12,000. Find the average cost of producing one pair of hand warmers if 50,000 are produced. So in this, remember that Q is number of units produced. So Q in this case equals 50,000. And it's as simple as plugging it in. So instead of putting Q there, I'm going to put 50,000 plus the 12,000. When I multiply that out, I end up with the expense equals 59,000 plus that 12,000. So my total expenses are $71,000. But that's $71,000 for the 50,000 that they produced. In order to find how much it is for just one pair, we're going to take that 71,000 and we're going to divide it by the 50,000 that were made at that price. And we find that the price for one hand warmer is $1.42. So the average cost to produce one hand warmer is that $1.42 when 50,000 are produced. Please press pause, go ahead and solve this, and when you're ready, come back. Okay, let's go ahead and look at this one. The expense function for a certain product is E equals 340Q, 3.4Q plus 189,000. Express the average cost of producing Q items algebraically. So it was simply plugging in what Q is. Well, it says Q is Q. And then if we look back at our last one, 50,000 is what went there. And our second step was to divide it by that. So after all is said and done, it's 3.4Q plus 189,000, all then divided by Q. Okay, example 3. Willie's Widgets have created a demand function for its widget, where Q is the quantity demanded and P is the price of one widget. We've got Q equals negative 112P plus 4,500, and the expense function is E equals 3Q plus 18,000. Express the expense function in terms of P. So what we're going to do here is we've got E equals 3 times Q. Well, from this equation, I know that this is Q, so I'm going to substitute it in for my value of P, and then add my $18,000, or $18,000 for my fixed expenses. Next step, I'm going to go ahead and distribute these, and I end up with E, or my expense, equals negative 336 times P plus 13,500 plus the 18,000. Combining my like terms, my expense function is negative 336P plus 31,500, which I got from adding these values together. And here is my expense function. Go ahead and press pause, solve this. When you're ready, come back and we'll finish it out. Okay, a corporation's expense function is E equals 4.00Q plus 78,000. Demand function was determined to be Q equals negative 4P plus 3,000. Express E in terms of P. So we're not doing anything different than we did the last question. It's E equals 4.0 times, we're going to substitute negative 4P plus 3,000 in for Q plus the 78,000. When I distribute, I get negative 16.00P plus 12,000 plus the 78,000. Next step, I'm going to go ahead and combine those like terms. And my expense equation is negative 16.00P plus, not equals, but plus 90,000. And there's our equation. Okay, example 4. Wally's Widget World created a monthly expense equation of E equals 1.10Q plus 4,200. Wally's Widget World plans to sell its widgets to retailers at a wholesale price of $2.50 a piece. How many widgets must be sold to hit the break-even point? So first thing that we have to recognize is that producing one of these is, so my revenue function is 2.50 times Q. The revenue is what I'm going to make selling each of them at $2.50 a piece times however many I'm selling. I've already identified my expense equation as the E equals 1.10 Q plus, not working here real quick, 1.10 Q plus 4,200. Sorry guys, not sure why this is doing this. All right, so the break-even point means where are they equal? Where does that revenue function equal my expense function? So I'm going to set them equal to each other. 2.50Q equals 1.10Q plus 4,200. Now it's just a basic algebra problem. I'm going to subtract 1.10Q from both sides, and I end up with 1.40Q equals the 42,000. When I divide both by the 1.40, I find that my break-even point is going to be at Q equals 3,000 widgets. So now we're going to have to go ahead and find the other side of our equation. We're going to go ahead and plug in Q. So I'm going to kind of put it up here. I'm running out of room. So the expense equals 1.10 times 3,000 plus the 4,200. When I go ahead and distribute this and then add them together, I get 7,500. So my break-even point, remember, when I'm looking at it on a graph, is going to be an X and a Y. And at that point, that is where I am going to break even, is at 3,700. Please press pause. Go ahead and solve this. When you're ready, come back and we'll finish this out. Okay, it says if the company sells 2,900 widgets, is Wally's Widget World operating above or below the break-even point? What is the difference between the revenue and the expense? So, looking at this, revenue equals the 2.5 times the 2,900. And I find that the revenue is $7,250. My expense is the 1.10 times 2,900 plus the 4,200, which equals 7,390. So if I take my expenses, how much it cost me to make them, and subtract how much I got for selling them, I am actually in the hole $140. So I'm below the break-even point, which means I still have not made money on this point, at this point. Okay, find the solution to example 4 algebraically. We really kind of already did that by setting it equal to each other. So 2.5Q equals 1.10Q plus the 4,200. 1.4Q equals the 4,200. And Q equals 3,000. Last you do, go ahead and press pause, solve this, come back when you're ready. Okay, find a break-even point for the expense function. So again, I'm just setting them equal to each other. 7.00Q equals 5.00Q plus 60,000. I'm going to subtract the 5Q from both sides. And I end up with 2Q equals 60,000. Divide by 2. And the break-even point is at 30,000. Plugging that in, it's going to be E equals 5 times the 30,000 plus the 60,000, which is $210,000 for my expense. So I'm looking at 30,000, 210,000. And that's it for this